So in this session, we're going to look at developing a REST API with the PowerBuilder C# IDE and then using that from PowerScript. So first we have a legal disclaimer, and then let's go over the agenda. So the first thing is I'm going to talk about myself for a little bit in case you don't know who I am. Then we'll talk about how we create a REST API using the .NET data store, how to do it manually, just so you can understand what all the different pieces are, what they do. Then we'll look at using the scaffolding feature that will automatically generate the REST API for us from a model. Then we'll look at the SQL Model Mapper version of the REST API. It's an alternative to using the .NET data store. We'll look at migrating PowerScript using the PowerScript migrator. We'll look at some features of the C# IDE, including NuGet integration. We'll look how we can secure the REST API using JSON Web Tokens, how we can test the service using both black box testing and then unit testing. And then we'll look at deploying the service to I'm going to use the Amazon Light Sail as an example of how to deploy the service. And then finally we'll look to see how we can then call that service using PowerBuilder. And then we'll have questions and answers. And throughout the session, I'll have different demos of the different options. So first, a little bit about myself. I've been using PowerBuilder since version 1. I was working for a county agency up in Summer County, California, and determined after using it for a while that this was something I could really make a living at as an independent contractor, and I did that for 15 years. Then as the PowerBuilder market started to decline, I decided it was time to go back to working for a full-time company, and I started with Integrated Data Services, the company I'm at now. I've been there 14 years. At the time I joined them, what they did was PowerBuilder client-server applications as an ISV. We've since migrated the vast majority of that to HTML5 JavaScript, but we do have a couple clients who are not in the cloud and never ever will be. That's their decision, and so they continue to use the PowerBuilder application, and we continue to maintain that for them. In addition to PowerBuilder, languages I'm fluent in are Oracle PL/SQL, Java, C#, C++. I'm also involved in a number of open source projects. I listed a few down there I thought were of most interest to PowerBuilder developers. A little bit about the company I work for. Okay, let's look at creating a REST API. So the first thing we're going to do is we're going to create what's called a data context. And in PowerBuilder terms, you can think of this as the transaction object, the SQL CA. There is a file called startup.cs that initially gets created when we create the project. We're going to register that data context. Essentially the same thing as the global variable SQL CA in the application object in PowerBuilder. We're going to generate a C# model from a data window. We're going to create a service then that uses that data model. We're going to create a controller that uses that service. Then we're going to take that service and we're going to register that as well in the startup.cs file. You might think of the startup.cs file as maybe the open event of your application, just to kind of give you some corresponding idea what it does. So let's look at how we do this. So this is the dialog you get when you indicate you want to create a new project in the C# IDE. And what we're going to select is ASP.NET Core Web API. Now there's a drop-down box on the left where we can specify either a basic project or one that contains a sample code for .NET Data Store or SQL Model Mapper. And for the purposes of this session, I'm going to just do basic because I'm going to actually go ahead and construct this stuff manually. Now, if you did use one of the two sample codes, what you could actually do is go in and just modify the sample code that's generated to change the data context and the data transfer object, and you would have a working application. But it would be, using whatever they provided in that sample code. In any event, once you decide you're going to create that project, there's 2 files that get created as part of that. I mentioned one a couple times earlier, the startup CS file. The other one is the program.cs file. So, in PowerBuilder terms, that might be like a constructor event on the application rather than the open event. Program.cs fires first. It calls the startup CS file. We will be working a bit, as indicated in the previous slide, with the startup CS file. We're not really going to do anything with the program CS file. So this is what's in the program CS file. Not a whole lot. It creates the web host builder and calls the startup file. So not a whole lot there. This is the startup CS file. Now, if you created a ASP.NET Web API project in something like Visual Studio, you would get those same 2 files. But the service startup file would be a little bit different. And when you create it here with the PowerBuilder C# IDE, you get some changes to the file that make use of PowerBuilder technology. A couple of the function calls here are the use core integrated and use PowerBuilder integrated. So those set up additional PowerBuilder related features in this project. The other one, there's actually 2 methods here. There is a configure services method, which we'll actually be touching several times throughout this, and then there's the configure method, which we will touch at one point, but we don't do so much with this. We spend most of our time with configure services. But anyway, here in the configure method, there's also this app.useDataWindow. So that's another place where a call is made that adds data window based capability to this project. Okay, so the question you're probably asking yourself is, why are there so many files here? Because we've already got 2 files, the program.cs file and the startup.cs file. But I mentioned that we're going to create a data context, we're going to create a model, we're going to create a service, we're going to create a controller. Why are we got so many files? Well, there's actually a really good reason for that. And that's because object-oriented programming has evolved since the initial development of PowerBuilder. PowerBuilder originally wasn't object-oriented. That's something that came about around the PowerBuilder 3 days. That's when object-oriented programming kind of came to the fore. And at the time, the thinking was that object-oriented programming languages should support encapsulation, inheritance, and polymorphism. And that's what PowerBuilder does. It does it real well. But what has happened is that design theories in object-oriented programming have evolved since then. And PowerBuilder hasn't really evolved with them. One thing that came out was the idea of design patterns, and when we talk about an MVC project, we're talking about the model view controller design pattern. That's what's being implemented there. That's something we're getting with this new approach, is we're actually implementing this more current, up-to-date method of object-oriented programming. If you want to get some more information on what design patterns are and what in particular model view controller is, I've got a couple of articles here that from the Coding Horror site that explain what those are, and I'd recommend taking a look at those if you're not familiar with them already. In addition, some design philosophies such as SOLID, which I mentioned here, and another one's called GRASP, have been developed recently. And what we're looking at in particular in the SOLID design theory is the idea of a single responsibility principle. That means if you have a class, what that class should focus on is doing one thing and doing that one thing well. You shouldn't have a class that attempts to do 2 or 3 different things and probably as a result not doing them as well as they could, as if they were separate objects. And so the idea is that you want to have one class that's responsible for interacting with the database. You want to have another class, a separate class, that's responsible for interacting with the user, that it listens on URLs and determines what to do in response to that. And then you have a third class that takes the direction from the class that's listening for the URLs, and then uses the class that's interacting with the data and puts together what the response is going to be. And that's what we end up with in Model View Controller. The model is what interacts with the database, the controller is what listens for the URL requests, and the service is what gets input from the controller about what the user wants to do, and then uses the model to generate the data that the user is asking for. So a couple of articles here as well, one from HackerMoon, the other one from CodeBag, that explain what the solid principles are. And then there's the idea of composition over inheritance. So the way that PowerBuilder implemented polymorphism is through inheritance. That if you have an object A and then you have a couple other objects B and C that need to implement that same behavior, but also have their own behaviors of their own, you would just inherit B and C from A. That has led to some issues, and we're going to cover what some of those issues are. And so what is actually favored now is the idea of interfaces. So what you do is you declare that an interface that has a particular set of methods, a particular behavior, and then you say class B and C implement that interface rather than inherit from an object A. And it tends to be a lot more flexible way of doing polymorphism. And there's a couple articles there. This one is from medium.com. This one's from codingdelight.com that talk about the difference between composition, which is using interfaces, rather than using inheritance to implement coding. So let's talk about some of those common issues are. And one example I give right out of PowerBuilder is the data store and the data window. So the data window came first. Originally in PowerBuilder, we didn't have a data store. And so if we wanted to do interaction with the database, and it wasn't something we wanted to display to the user, what we would do is we would put a data window on a window and then make it invisible. And that was our data store. So PowerSoft recognized that was something we needed. We needed the ability to interact with the database without displaying something to the user, and so they introduced the data store. Now, what would have made sense, likely, using inheritance, is that they could have made the data store the ancestor of data window, but that's hard to do once the data window's been around for a while. And that's why what actually happened in PowerBuilder is that the only object that data store and data window have in common is PowerObject. They don't inherit from each other at all. And that means, I haven't looked at the code underneath, but it likely means that there's no real reuse going on. That even though the data store and the data window have many of the same methods, it's likely that they were coded separately from one another. Let's say you have another example. This would be in your coding. Let's say you have a set of objects that inherit from one another. You have a class A that has a certain behavior, and then you have a class B that you inherited from that, and then you extended it to have some custom behavior of its own. And then you realized, B really should have inherited from C rather than A. Well, the problem is that's hard to correct in PowerBuilder. It means you have to basically open up the source code in a text editor, go through and find the references to A and change it to C. And it's tedious and it's error prone. It's not something that's natively supported in PowerBuilder. Or you have, let's say, an object A, and then you inherit from that an object B, which has its own special behaviors as well. You inherit an object C from A, and it has its own special behaviors. And then you realize later that I have an object D. And what object D needs to do is what object B does and what object C does. Well, we don't have multiple inheritance in PowerBuilder. There's no way for us to say D inherits from both B and C. So what we'd have to do is we'd have to pick one of the two, either B or C, and then extend D with the behaviors that are in C as well. Let's say if we inherited it from B. Yeah, so that's an issue. There's no really good way to implement that in PowerBuilder. With interfaces, it's a lot simpler. If you decide that an object B, going back to the second example, should be implementing C rather than A, you go into the initial class declaration and you change the name of the interface that you say that class inherits from. Not inherits from, that implements. You have to do some additional coding work, but it's directly supported by the IDEs. It's just a matter of determining what methods are now on that new interface that's being implemented, that have to be implemented in order to fully implement the interface and make sure they're coded. And then the same thing with the second option. If you decide that the class needs to have the behaviors of both interfaces B and C, you just declare in its class declaration that it implements both of those interfaces, and you get both behaviors. So we have a model that's going to have our data context class. That's essentially our SQL CA. We're going to have the model, which is often called as well. There's actually two pieces to it. And they're kind of merged together here in the PowerBuilder C# generation. You usually have a model and you have POCO classes. Now POCO stands, depending on your viewpoint, either plain old CLR objects or plain old C# objects. Anyway, they're the equivalent in Java as the POJO object, plain old Java objects. Basically, in PowerBuilder terms, it's you can think of them as either a structure or a non-visual object with instance variables and no methods or events. It's just a container for holding the data as it's transported between layers. That's independent of where the data came from. So the only thing that really knows where the data came from is the actual model class, or the data access object, I should say, that talks to the data, to the database or wherever the data is coming from. It puts that data into the POCO objects, and then the POCO objects are passed up through the remainder of the app. So this is what I was talking about, the data access objects. Like I said, in what we're going to generate, we actually somewhat merge these two together, and we'll cover that when we get there. Then there's the view, and in this case, this would be the services. So there'll be a service interface, and there'll be a class that implements the interface, and that becomes important later on. Excuse me. When we do things like look at unit testing, where we might want to create a mock service for your unit testing. Just one example of why interfaces become important there. And then finally we have the controller. This is the thing that listens for the URLs. It calls the service. The service then calls the data access class to get the data and return it to the controller. Okay, so let's look at how we do this. We're going to go into our brand new project that we just created. Right click on it, and this is something I like to do, and it's actually pretty common among people who do MVC architecture, is we create folders that's named models, another folder named controllers, and then another folder named either view or services. In this case, this will actually be services, since this is not a visual application. So we'll go ahead and create those folders. So I'm going to create a folder called models. I'm going to get into that folder. I'm going to say add new item. And this dialog appears. I'm going to select data context, and I'm going to give it a name. And what's going to appear is this dialog. So this dialog is saying, okay, you're basically creating a transaction object. Tell me what database we're talking to. And if you've defined some other database interfaces before, some other data context. This drop-down list box will be populated with a list of the ones you've created before. Otherwise, you can hit the New button, and that will show you a dialog I'll show you here in a minute, which allows you to specify the connection information. That results in this connection string down here. That gets saved out into a application configuration file. And the reason that's done is that when we get done here and you test your application and it works, and you want to deploy it into a different environment, you may have a different database you want to connect to. You may have a database for your development, database for testing, and then you have your production database. And by putting the database settings in a configuration file, it means we can just change the configuration file to point to the different databases as the application moves from development to test to production without having to recompile the application. So this drop-down list box here, and we'll see it in the new dialog as well. This indicates what particular database we are going to work with, the vendor essentially. And so the supported databases are Microsoft SQL Server, Oracle, and PostgreSQL. In addition to that, there is support for the ODBC driver. And if you're going to use SQL Anywhere, that's where you're going to go. SQL Anywhere is officially supported by Appeon through the ODBC driver. So if you do run into problems with it, you can report them to Appeon, and Appeon will address them. You can call other databases as well, but they are not officially supported through ODBC. So I mean, you can file the bug reports, but Appeon may not give them quite the same priority as they do for SQL Anywhere. So here, if I hit the new dialog, the new button, I'm sorry, this is the dialog that would appear. So here's that drop down where you can select the database you're going to work with, and then depending which one you select, you may get different options here about how to connect to that particular database. Test your connection. If it works, hit OK, and then it takes you back to that previous dialog. So here's our data context. Not a whole lot to it, and we're not going to do anything with it. That's just what gets generated. Okay. Now we need to generate a C# model, and I should point out too, that's unless you're going to be working with multiple databases, you do that step once. This next step, most of these other steps, you're going to be doing over and over again as you develop additional services. So the first thing we're going to do is we're going to create a C# model from a data window. Since we already have a data window, the idea here is we already had a data window that we wanted to migrate over to this. So what we're going to do first of all is we're going to go into our solution, and we're going to right click and select Open PB Workspace. And what that's going to do is it's going to open up a dialog that allows us to navigate down to wherever our workspace file is. We select that, and all the targets that are in that particular workspace are now going to show up in the C# IDE. And you can expand these, and you'll see the libraries, and then you'll see the individual objects. And that will become important not only here when we're doing the C# model from the data window, but later when we get to the PowerScript migrator. This is how we'll navigate to the objects that we want to migrate the PowerScript for as well. So here I've opened up a target. There's the library. Here's the data window that's in that particular library that I want to create the C# model for. I right click on it and select the convert data window to C# model. And it's going to prompt me with that same dialog we had earlier when we were creating the data context, because we're interacting with the database when we were using this converter. So just go ahead and select that same database. And this dialog appears, or this, I should say this painter appears. There's a bunch of settings we can change on here. Later on, when we get to the scaffolding, we're actually going to modify one of those settings. But for now, I'm just going to use this button in the upper right-hand corner, and that actually does the export. So it's going to give me a dialog that says, okay, where do you want me to put this data model? And like I said earlier, I like to have everything's all the model-related stuff in a models folder. So I'm going to use this browse button here, the second one, to navigate to the models folder that I actually want to have this model put in, and hit export. Now I'm going to go back to my Solution Explorer here, and you'll notice that underneath my models folder now we have a reference to the workspace, a reference to the PBL, the PBD, the target. This folder has been created for each one of these. So there's a reference to the workspace, a reference folder for the workspace, folder for the target, folder for the PBL, and there's our it's sort of a combination data access class POCO object that we've created. If you open up and look at it, you'll see down here where it starts off with public class D_customers, everything down below here, that's the POCO object. That's just essentially the structure, the non-visual object with instance variables that we're going to be using to just transport data throughout the application. The section that comes before this has a lot of information that was exported from the data window, including the select clause from the data window. You'll notice though that it has C columns placeholder here. What that does is it reads the attributes down in the POCO class. So if we wanted to add or delete a column from the select, we wouldn't need to change the SQL statement. All we have to do is add or remove the column from the POCO object, and it would automatically change the SQL statement. Okay. So now we're going to go back to the startup CS file, and we could have done this actually before we exported the data model. This actually has to do with registering the data context. So I'm going into the startup CS file. I'm going to add a couple using clauses. This is for Snap Objects. That's the open source library that Appeon provides with the C# IDE. That it's their version of if you're familiar with .NET environment, Entity Framework, or if you're a Java developer, you might have heard of Hibernate. Those are ORMs, Object Relational Mappers. What they do is they take a relational database, which is not particularly object-oriented, and creates classes from that proxy the database, and then can be used in an object-oriented environment. So the reason that Appeon decided to create their own ORM rather than using something like Entity Framework is that they found Entity Framework was difficult for people like PowerBuilder developers who are trying to learn this technology. Found it was difficult for them to pick up, and they found that Entity Framework was rather slow, and so they came up with something that was faster, and it was easier for people to get started on. Now, right now, we're only using the data context. When we get to the SQL model mapper, we'll use more of Snap Objects. So once I got those using clauses in there, actually I'm going to add one more thing. I'm going to add a using clauses for the models folder, because I'm going to be referencing the data context that we generated there. Then you might have seen it earlier when the startup CS file was created. There was a bunch of lines of code in the configure services that was commented out, and what that is declarations for adding the data context for each of the supported databases. So what we can do is we can just find the one that, in this case I'm using SQL Server. I'll just find the one that was commented out for SQL Server, uncomment it, and then make a couple changes to it. One is I need to give it the name of the data context, and the other one is I needed to give it the key value in the properties file for the transaction information, the connect string. So I make those two changes, and we've registered the data context. So now our application basically has a SQL CA they can use. And so we've got our data context, we've got our model. What we need to do now is create our service interface and then the actual implementing class. So I'm going to create my services folder. I'm going to right click on that, say add new item, and then select interface. Give it a name, and by convention, interfaces begin with a capital I and then the name of whatever service will eventually implement them. So I called mine iRest demo service. So this is basically all that gets generated. It's pretty bare. We're going to add a using clause for dwnet.data. Now this is the other half of the classes that Appeon is providing with Snap Objects, at least in the Universal Edition and above. The issue here is that while Snap Objects is open source, the stuff in dwnet.data, that's the explicit data window technology that is licensed. SAP still owns the IP on that, so it can't be provided as open source. So it's in that separate namespace. That's where the .NET Data Store is at. If you're going to use the SQL Model Mapper, the SQL Model Mapper is part of Snap Objects rather than dwnet.data. So you can use that without having to worry about the licensed nature of dwnet.data. But the advantage of dwnet.data is that it is a very PowerScript-like implementation of the .NET of the data window. And so if you're doing a migration from two-tier PowerBuilder app to a three-tier with services in the middle, and you don't want to learn a new syntax for retrieving the data, you'll find the .NET Data Store much easier to use, because you're going to use pretty much the same syntax you're already comfortable with to access the data. And we'll see that when we go farther into the demo. So what I've done here now, I've done the using clause. I'm going to add the methods that I'm going to implement. Now, for the purposes of this walkthrough, I'm only going to implement two methods, a get method and an update method. And technically, if you're using the .NET Data Store, that's really the only two you need. There's going to be a difference, and we'll get into it later on, between how the .NET Data Store handles updates and how a normal REST web service handles updates. And REST web services by default are stateless. They don't contain state information. So when you get a bunch of data down from a service, you get a bunch of data down from a service, it's just data. But when you go to send it back, you can't send back a bunch of data and say insert these rows, delete these rows, and update these rows, because they don't. That's state information. That's not the way REST is normally done. Where REST is normally done is that you have add methods in your service, you have delete methods in your service, and you have update methods in your service, and you make separate calls for the separate different kinds of updates. It's not a hard and fast rule, because the REST side web services I create, we also do pass metadata, and we can actually do all three updates in a single call, and we actually do that. But anyway, so that's why we would only need a retrieve and an update. Now, what I'm going to do, at least for the sample code for this session, is I'm actually going to create not only the get and update, but a get one, an add, and a delete as well. And so you'll be able to see how you can implement all of those. And we'll do that same thing with the SQL Model Mapper service as well. But for the purposes of walkthrough, we're just going to focus on these two. So I have the getAll method, which gets all the data, and then I have the update. Now notice that both this one returns an iData store and it takes an iData store in by reference. So this is our clue that we're going to be handling the JSON that's submitted by to this application in what's called the data store or data window JSON format, the one that has the metadata in it. Okay, so I've got an interface. It's actually a pretty simple file. So now I need the implementing class. Once again, I'm actually going to create a folder underneath my services called impl, and that's just another technique that I like to do. So my interfaces are actually separate from the classes that implement them. And once I've got that folder created, I'm going to say add new item class, give it a name. It's going to be pretty bare bones as well when it's first generated. This is where we start using interfaces. So first thing I'm going to do is actually put in a using clause for dw.data again, because this is also going to make references to the iData store. I'll put a colon behind the class name and add in the service interface that I'm implementing. Now the minute I do that, I'm going to get this red squiggly line underneath the name of the interface. And that's the IDE's way of telling me, well, you said you implement this interface, but you don't have methods that implement the interface methods that need to be implemented. And if I hover over that red squiggly line, then this little dialog comes up that tells me that gives me that information. It tells me there's this getAll and update method that you need to implement. And there's option here that says show potential fixes. You click on that, and this pops up, and it gives you a couple options here. We're going to select the implement interface option. And what that's going to do is it's going to copy the methods out of the interface and paste them into our class. So this is a nice little shortcut that the IDE provides just to help you make your coding go faster. I could have gone back and opened up the service interface, copied out the methods and pasted them here, but it would take me a little bit more work. So this was a little time-saving feature. So anyway, these are the two methods I need to implement in order to truly implement the interface. And so now what I'm going to do is I'm going to go back and I'm going to add a reference to the models folder, because I need the data context so that I can because the service calls the model, and so the service is going to need to know how it's going to actually do it needs to call the model. And so I'm going to add the data context there, or the reference to the model folder I should say. I'm going to create an instance variable in the class of the data context class, and then I'm going to create a constructor on the this is a custom constructor for the REST demo service, which takes the data context as an argument, and then I'm going to assign it to that variable the instance variable I created earlier. Now this thing with this underscore that I've got in the front of the instance of the instance variable name, that's just a coding technique I like. There are some languages out there, if you name an argument to a method the same as a variable and do the assignment, it won't actually use the variable, it will use the instance variable. Basically assign the instance variable to itself. Now that's not, the C# does not do that. C# would actually do this correctly, but because I work in a number of different development languages and some have that limitation, I just do this to be kind of code safe wherever I'm at. So anyway, I get a lot of questions about what that underscore is doing there, and that's why I do that. So anyway, you don't have to worry about actually creating this service and passing in the data context. Once you've created this public constructor on here, the framework, the ASP.NET Web API framework will take care of that for you. So when it creates the service, it will automatically create the data context and pass it in. Now we're just doing that so then when we get these methods down here later, we've already got essentially a SQL CA available that we can just use. We don't have to worry about creating the transaction object every time. So here's our my getAll method. And so what I'm going to do is I'm going to create my iData store by saying new data store. This is the POCO object that was generated from the data window, and this is our data context. Now think of this in terms of, now PowerBuilder doesn't have the constructors for its classes that take arguments. So what happens is, what you would do in PowerScript is you'd say data store equal data store equal create data store, and then you would say data store dot set object and give it the data window name, and then you would say set trans object and give it the transaction object you're going to use. Now since C# does have constructors that take arguments, we're actually doing all that in one step. But that's essentially what's going on here. So that should be a fairly easy migration, if you will. This is something that your PowerBuilder developers should pick up on pretty quick. That I'm creating a data store using basically a data window and giving it a transaction object. So there's my data store. Then I'm going to do retrieve on it. Really simple. That's what we did in PowerBuilder. That's what we're doing here. We're doing a dot retrieve. Now the reason I've got -1 here is, and this is just the way I coded the data window. I coded it so that if it gets a positive number in the where clause, if it gets a positive number, it goes and finds that particular customer. If I have a negative value, it doesn't have to be -1. Any negative value, it just ignores the argument and returns all the customers. So that was just a little method of cheating on my part, so that I could use the same data window to return a list and to return a single a customer. In any event, I retrieve the data window, and then I just or the data store, and then return it because that's actually the return from this method. Here's our update. The data store is coming in by reference. I'm doing essentially a set trans object on it, but what I'm doing here is actually dot data context equal the data context. But once again, that's a pretty one-to-one between PowerBuilder, PowerScript, and the C# syntax. So your PowerBuilder developers should pick up on this really quick, and particularly this next one should be really familiar to them. You just take the data store and do an update on it, and the return value will be the success or error code for the update, and then we just return that. So pretty easy conversion for your PowerBuilder developers. They don't have to learn a lot of new syntax here. Okay, we've got our data model, we've got our service and its interface. We need to create a controller. This is the thing that actually listens for URL requests and then figures out what to do based on that. So I'm going to go to my controllers folder, right click on it, select add new item, select API controller class, and what SnapObjects does is actually creates a template, even in this basic mode, creates a template that has like a load one, an update, delete, add, I don't think I said add yet, add methods. So what I'm going to do here is I'm going to just take the two that I need, the load and the update. I'm going to leave those in there and then modify them for what I need to, because the arguments are wrong here. I need to change them to the arguments I'm going to be using. And then the others, at least for now, the load one, delete and add, I'm just going to remove. Now, like I said, in the sample code, I'll actually implement those. But for the walkthrough, I'm not going to do that. So, like I did with the service, remember the service declared an instance variable of the data context, and then took it in on the constructor, we're going to do the same thing with the controller. And once again, like the service, once we've done this with the controller, we don't need to do it. We don't have to worry about actually doing it later on in some other code. The framework handles this for us. So when the service goes to use when the application goes to use the controller, it will know that it needs to create the service and pass it in as an argument. So I'm going to add a reference to the services folder because I'm going to be referencing that service. Declare an instance variable to service, pass it on the controller, and set the variable based on the passed in service. Now I'm going to add a bunch of other using clauses here. One's the system.links. I'm going to add the model folder because I'm going to be using the POCO object. I'm going to be adding dw.data because I'm going to be using the iData store. And then I'm going to be using Microsoft ASP.NET Core.http because I'm going to be referencing different return codes that the service could provide. I'm going to go down to the, this is the load method. And what I'm going to do is I'm going to add produces response type 500. So that's one of those HTTP codes I was referring to. I'm going to change the result. It was action result already, but I'm going to change it to a list of D customers. That's our POCO class. So it's returning an array of the POCO class out of the load method. Then I'm going to say that the data store, I'm going to declare a variable of the data store and just call the service method. I'm going to check the row count. Now if the row count is 0, then something happened. Something went wrong. And I'm going to raise this not found. Otherwise, though, I'm just going to take the data store, and rather than return the data store directly, I'm just going to create a list of the POCO class from it and return that. The main thing is I don't need, when I'm doing a retrieve, I don't need the state information. It's only when I do the update that I need state information. So I don't need to pass back the iData store here. I can just pass back the bare class. Now this is the update method. Same thing. I'm going to add this produces response type 500 here as an attribute here. I'm going to change the argument here to iData store. Now this is where I do need the metadata, and so I will be taking in an iData store on the controller. What I'm going to do then is just declare an instance variable. I'm not a local variable that takes the return back from the service method call, and so I just call the service, passing in the data store. Now if I get a -1, that means the update failed, and so I'm going to return a 500 error code. And the 500 error code in REST services means it blew up. Otherwise, I'm going to return OK. It just means that the update worked. Also, I've got this wrapped in a try block, so if there's an exception, I will also return a 500 error code, except this time I'll actually return the message from the exception as well. As I mentioned, I'm not showing the other methods here, but they are available in the demo code that's available for the session. So this is the step I always forget. And so we have a controller, we got the services, we got our model, data context, we got all the pieces together, but we need to tell the application that the service is available. And so we need to go back to the startup CS file, and I'm going to add in references in the using section to the services folder and the service implementation folder. And then here's where we added the add data context. So down below that, I'm going to add this statement: add scope. Then I'm going to give the name of the service interface and the name of the service, and we're done. That's what we need. That's the only thing we need to do to let the application know that there's a controller out there listening on a certain particular set of URLs. Now, you may have wondered, wait a minute, it's listed on URLs, but what URLs is it listing on? Well, this is how that's determined. So at the very top of this is the controller. So at the very top, there's this route API / now this is the word controller in brackets / the word action in brackets. Now, what the application does then is when it sees the name controller, the word controller in brackets, it's going to go find the name of the controller. So this is called REST demo controller. It's going to strip off the word controller off the end here, take what's left, REST demo, insert it in that URL. So now the base URL we're dealing with is API / REST demo /. Then it looks at that square bracket action, and it's going to go find the method name. And it's going to take that method name and put it there. So now for the load method, it's API / REST demo / load, and then my update will be API / REST demo / update. So that's where the URL it listens for comes from. Now, you may have noticed this earlier when I was showing you the update method. There's also this declaration here that says from body. Now, that's not actually necessary to make the C# code work. It will still work either way. What that's going to primarily help us with is later when we talk about NuGet and we talk about how we can add. We're specifically going to look at how we can add a utility called Swagger to the application. What Swagger does is it helps you document your REST APIs. And so Swagger looks for this declaration because Swagger doesn't know where that argument's coming from. When you do a post, you can pass in data either on the URL itself or in the body. And if Swagger was looking at this, it wouldn't know where that argument was coming from. And so this is the declaration that Swagger is going to use. Excuse me. That Swagger is going to use to know that this argument comes from the body rather than from the URL. Okay, last thing we're going to do, this is the properties of the target. And there is a debug tab here. I managed to partially cut it off there when I took this screenshot. But essentially, in any event, there's a debug tab there. And when you go to the debug tab, there's an option here to automatically launch the browser to a particular URL when you go into debug mode. And there's a value actually provided there by default when the C# IDE created the target here, but it's not the one we want. So I'm going to go in here and change it so that it calls the load method whenever I run the service out of the IDE. Now once I'm done here, I press F5. That's going to compile the application. It's going to run a self-hosted web server, and which listens on port 5000 and 5001. And then it's going to run the service, this application, and it's going to launch a browser and call that URL. Now the first time you do that on a machine, you'll get this prompt. Now the reason you're getting this prompt is because, remember I said it was listening on 5001 for HTTPS. You need an SSL certificate to do that. It's going to generate a self-signed certificate, SSL certificate, and you need to install that on the machine. This is a one-time operation. So once you indicated that yes, I'm going ahead, I want to go ahead and install that self-signed certificate, then you can use SSL here, and you only get prompted for that once. And so then it calls. There's this. This is the IDE in the background. This is the self-hosted web server that's running, and this is the browser that was launched. This happens to be Firefox, and this is the way it displays JSON that gets returned. So our service is working. You don't have to do it this way. One thing you can do is you can if you want to just run it manually, is you can go to the folder the bin folder that the code got generated into, What you'll need to do though is you'll need to copy the app settings.json file into that folder if you haven't got it marked to automatically deploy with the bin files. That's so that the service can find the connection string for the database. But then you go to that folder, open up command prompt, type .net, the word .net space, and then the name of the assembly, and it will also launch the service through a self-hosted web server. And then you can open up a browser or Postman or whatever you want to use to test the service and start making calls. So that is sort of the long explanation of how we create a service. Now we're going to look at the shorter way to do it. This is probably the way you're going to end up doing it, but it's important to know what all the pieces are, what they're there for, and how to code them, so that you can go in and do maintenance and understand what all the pieces are. So this is using the scaffolding feature. So basically it's going to do everything I just did manually. It's going to do pretty much automatically. There's a few pieces we still have to do. We have to create the data context. We have to register that in the startup CS file. We have to create the data model. We can generate the service controller from the data model though, and then once we're done with that, we still have to register that in the service by editing the startup CS file again. But a big chunk of the work is taken care of for us. So let's say I've gone, I've created my data context already. I want to create the same way we did before. But now I want to create the C# data model from the data store again, the data window again. But this time I'm gonna stop and make a change here, because what I'm going to do, one of the options here, I click this drop down, and I'm editing this value here, and what that value is, that's the name of the class that's going to be generated. So what I did, and what probably 95 to 99% of PowerBuilder developers do, is when I created a data window, I called it d_something. Okay, so what this converter does by default is it just takes whatever the data window name is and generates the POCO class with that same name. So if you remember, my POCO class was called d_customers. That's fine for a POCO object, but when we create a service and controller from the model, it's going to create the service controller names using the name of the model, which it would default to d_customers. So we'll end up with d_customers service and d_customers controller. And then because the URL for our service is based on the controller name, our URL starting off with d_, which isn't pretty. So anyway, long way of saying we want to go in and change the class name that's used for the model here to take off the d_, and that's what I did here. So now the class I'm going to generate is just called customers. Now that I have the customers data model, I'm going to right click on my models folder and choose the scaffold option, and then I'm going to choose the option to create the service controller from the model. Now you notice there's other options there. You can create a controller, just a controller from the service if you've already created a service, and then there's different options using either the data store or the SQL model mapper, which we haven't talked about yet. But I'm going to check that second option. I've got the model that I generated from the data window. Go ahead and create my service controller for me. It opens up this dialog. Now this is, when I'm doing this session, we're still in the beta for 2019 R2, and the scaffolding is a 2019 R2 feature. So some of the edges are a little rough here. One of those is the name of the templates here. Basically, they called the templates A, B, and C. I imagine by the time this gets released, they'll have a little bit more meaningful names for it. And there's some other options here as well, but that's probably the primary thing we're interested in. So the three templates are, one is to create a data store based .NET data create a .NET data store based service and controller that have the retrieve and update methods only, just like what I did for the walkthrough. As I mentioned, if you're using PowerBuilder as a client, we really don't need the separate add and delete methods, because we can send the updates, the adds and deletes with the update method, because we're going to be passing back metadata with the update that can tell the service to do adds and deletes on those rows. So that's template A, just the retrieve and update methods. We have a template B. B does not only the retrieve and updates, but also creates retrieve one, create and delete methods. So if you want to have calls to your service that do the adds and deletes separately, you can do that if you use template B. And then template C, and I really didn't cover this quite yet. I was saving some of this for the SQL Model Mapper. The SQL Model Mapper creates what I will call a client agnostic method. That means that it returns plain JSON and doesn't have state information, and so it will have the create, update, and delete methods separate. And that means that you can call it from any client. It doesn't have to be PowerBuilder. Anything that handles a REST service can call these methods. The .NET Data Store can also pass plain JSON as well. So you don't have to use the SQL Model Mapper to create a client agnostic service. You can tell the data window to generate plain JSON instead, and then use the client agnostic methods, the create, update, particularly the separate create, update, and delete methods using plain JSON. So that's really where this third option goes, is that, and it's actually kind of nice, because what it does is it creates both the data store specific and client agnostic methods using the data store. And so you have one service that can be used both by PowerBuilder and well, if you created a client agnostic method, you can use it from PowerBuilder as well. But excuse me, what this template C does is creates methods that support the metadata approach the data store uses and the client agnostic methods. So there's some particular advantages to the data store approach that actually are in a sense an improvement over REST. And I'll go ahead and touch on that here. Because REST is stateless, you get data down. You send data back. You say, I want to update this row. There's no way to tell a normal REST service that you updated columns 3 and 4, and those are the only 2 columns you updated. There's no way for the REST service to compare the original values of those columns with the values that you're passing up. What we had with PowerBuilder, the data window supported optimistic concurrency. The idea was that when you did an update, the data window would check to see what the original column values were, and if there was a change to any of the column values from when you retrieved it, you know you have an update collision. You know that some other user has updated that row while you were looking at the data. And then you could deal with that. You could also just update individual columns. It would dynamically generate the SQL, so that if you only updated columns 1 and 3, 1 and 3 were the only 2 columns you updated. REST services don't work like that. Normal REST services don't work like that. If you send an update, it's going to take every column that's in your update statement and use those values. And so you can very easily do an overwrite over somebody else's changes using REST. The only way to really prevent against that is to add something like a timestamp column or a GUID to the row. So, and then not let the client modify that, and then compare those on the update. And if you don't get the same timestamp value or don't get the same GUID that you had on the original retrieve, then you know you've got an update conflict. But that means you're going to be doing a lot of work to add that to your database. Anyway, sort of a rabbit hole there. That's what template C does. It gives you both the more powerful .NET Data Store update approach and the client agnostic update approach. So this is what got created. We've got our customers class. That's what we exported. Then we've got our iCustomer service and customer service, service interface and service, and the custom controller. All the customer controller, which is our controller, all generated for us automatically. The red is generated for us automatically. The blue is what we exported. But we still have to do one more thing. The part I always forget is we need to register the service in the startup CS file. Okay, let's do a demo of the scaffolding feature, and then we'll come back and we'll talk about the SQL model mapper. Okay, so here we are in the C# IDE. I'm going to say create new project. I'm going to make sure I've selected ASP.NET Core Web API. I've got basic down here. I'm going to call this something like scaffolding demo. Click OK. And in a couple seconds we'll have the solution created with the two files I mentioned, the program file and the startup file. And it created a controllers folder for us already with a sample controller that I don't really want. But I'm going to go over here and say add. It takes just a couple seconds before this thing's really ready. There we go. So I'm going to say add new folder, and I'll call it models. And I'm going to go ahead and delete that sample controller. I don't really want it. Okay, so now I'm going to go in and say on my models folder, add new item, data context, and call it demo data context. Now I'm going to be using AdventureWorks, so I'm just going to click OK here, and it's going to create. Well, the app.json file is there already, but it's going to add this connection string to that file. And that's my data context. I really don't need to do anything more with that. I'm going to click on the solution, say add PB workspace, and then I'm going to go find my workspace that has all my targets in it. And I'm going to go to this one right here. That's the data window right there that I want to create the service. Actually, let's use this one right here. I want to create the service for. All right, click on it, say convert data window to C# model. Maybe just a second here. There we go. This is the converter. It's prompting for the connection. I'm just going to accept the same connection. This is where I'm going to pop this guy open and just change the class name here. So it's just customers. Okay. Click the export, and here I'm going to indicate that I want this to be in my models folder. Click export. Okay. So we're done here. Now I'm going to go in and startup file, and we need to add the data context. So I'm going to uncomment this line and then change this to say the name of our model, which was demo data context. And we're going to get a red squiggly on that because I haven't done any of the imports. So I'll hover over the red squiggly, and it'll say, well, do you want to you add this using clause? So I'm going to add the using clause, and that's going to take care of scaffolding data demo context, but I'm still getting an error. And so I'm going to say other potential fixes again, and it's telling me I don't have snap objects data in the using clauses. So I did that. I'm still getting a red squiggly because we added the dot data, but we didn't add dot data to SQL Server. Now I've added that. No more red squigglies, but we do have the improper connect string, and just to make sure I don't make any mistakes, I'm just going to copy it out of the config file and put it right there. Okay, so now our data context is created, or actually it's created, not only created, but it's registered with the service. I'm going to take the model now, right click there, say scaffold, create service controller from data model. And I'm going to just leave it with A, that's the one that creates the retrieve and update methods alone. I'm just going to hit OK. And now we have the services, where there's the interface, there's the actual service, there's the controller. One more step we need to do here. We need to go in here and say services.add scope, the name of the interface, so it's customers service, and the name of the implementing class, there's supposed to be a comma there, which will be customer service. Close that bracket, parens. We're still getting a red squiggly. Nope, the red squiggly went away, so we're good. Okay. So let's go to the properties for the target. And here's that debug tab that I chopped off in my slide. I'm going to change the API it calls to customers load. Let's look at the controller just to make sure that's what it is. It's actually retrieve. Okay. Okay. I'm going to save that. Fingers crossed. We'll hit F5. So it's building the project. There we go. Done building. The build worked. It's launching the self-contained web host. And it's launching the browser. Browser's calling the service. And we got data back. So just like that, we've got a working service that does retrieve and updates in that quickly. Okay, so that's the scaffolding feature. Okay, so now we're going to talk about the SQL Model Mapper. And as I alluded to a little earlier in the session, the SQL Model Mapper uses plain JSON. It's the client agnostic approach, although you can do a client agnostic in .NET Data Store as well. But it's also got some additional features that aren't supported by the .NET Data Store. So it's something to look at. You'll want to use the .NET Data Store to get started, and then once you're familiar with the services, and then you might want to look at see whether or not the SQL Model Mapper might have some features. Some of the features of the SQL Model Mapper are something that you might want to take advantage of. As I mentioned earlier in the session as well, it's completely open source. There's no dependence on data window technology. So this is actually provided with the standard version of, or will be provided with the standard version of PowerBuilder when 2019 R2 when it's released. It's not the universal sorry, yeah, not the universal version. You have to have the universal or above to use .NET Data Store. Okay. It has a pure separation concerns. You remember earlier in the session I talked about how the data access object and the POCO object are somewhat merged in the .NET Data Store approach. It does have a steeper learning curve for PowerBuilder developers. It's not going to be .retrieve, .update. It's going to take a little bit more work if you're not familiar with C#. If you are familiar with C#, particularly if you're an Entity Framework developer or got some .NET Framework experience already, it'll probably be a lot more comfortable for you. It'll be something you would probably recognize fairly easily. The SQL Model Mapper uses bare data classes rather than the custom classes like iDataStore. And like I said, it has additional capabilities. So it supports complex implicit transactions. You can basically chain together several different updates and then commit or roll them back as a group. You can have nested models. One limitation of anything data window based is the data window only supports a single set of rows and columns. It's a two-dimensional array. You can't do anything really that's like parent-child relationships, multiple result sets, anything beyond just a simple flat two-dimensional data set. And you can use raw SQL in the model. So you can say, do this update using this model, issue this SQL statement, and do this other model update. And as I mentioned, you can put all this together in a single transaction as well. So there's a lot more capability in that regard. But it, like I said, it is it's going to be more of a learning curve for your PowerBuilder developers. So we'll need a SQL Model Mapper data class, and so I cheated in a sense. I just took the one that I had generated from my data window for my .NET Data Store service, and I just chopped out the stuff that I didn't need here. So it's just a POCO object now. Now I'm going to create a service interface. Now, remember before I only had the 2 methods. Now I do have all 5 because this is going to be the plain JSON. It's not going to contain metadata. I'm not going to be able to do creates and deletes through my update. So I'm going to have separate methods for that. Notice that rather than passing back the iDataStore, I'm going to be passing back an iList of the POCO object for the retrieve. The retrieve one is going to just return the POCO object, and the update will just take once again a list of the POCO object. Okay. Now this doesn't really change much. When you're creating your service, you're going to take in the data context, pass it into an instance variable. But here's where you're going to see big changes. So here's my retrieve method. Now here what we're going to say is I'm going to take my data context, I'm going to call the SQL Model Mapper on that and call its load method, indicating that what I should be getting back is SQL Model Mapper, the POCO object, and doing a to list on it. Now I have the retrieve one method listed here. The only reason I'm showing it here is because I actually use it in my update statement. So all it does is does a load by key rather than just a load, and it takes in the ID value and then returns that one particular POCO object. Here's my update. So the update takes in the list of customers, and what I'm doing here, the way I'm figuring out what changed for my update statement is I'm looping through the customers that were passed in, and I'm retrieving the current customer data from the database. This is where my retrieve one method is being used. So now I have the the data was passed into me, a customer that was passed into me because I'm looping through. I have the current customer data from the database, and I compare the two. That's what this track update does. So I say SQL model mapper.track update compares the two values. If it finds new values on the data that's being passed in, it copies those values onto the row that I retrieved from the database. And now I can say save changes, and it knows what the changes are because it knows what it copied over. It knows that these particular columns were updated, these particular rows were updated. So that's what it applies those changes to the database. Okay, here's my controller. It's a little different. These using clauses really didn't change too much. In the instance variable, and that part didn't really change. But we don't need to add data window.net.data because we're not using data window technology. Same thing with the service. That we didn't need that as well because we're not using the .NET data store. We're not using the licensed software. We're using just the open source stuff here. So here is my load and update methods. So because my return argument from my service is a little bit different, this is going to be a little bit different as well. Notice, well, actually, this is essentially the same as what I had for my load method in my .NET data store approach, because I did return just a list of the POCO object there. But the way I get it back out of the service is a little bit different. Also, here's my update method, and this one actually isn't really any different, except for the argument here. So I'm getting, rather than getting the data store, I'm just getting the list of the customers. I just pass that into the service, check my count. But other than that, it looks pretty much the same as the .NET data store approach. It's just that the argument changed. But most of the difference is in the service layer. And then once again, we'll update the startup CS file and add scoped to indicate the interface and then the actual name of the implementing class there. Now let's look at how we can, what we've talked about so far is taking the actual data window retrieves, data window updates, and moving them into the service layer. There's probably at some point some business logic that we want to move there as well. Not UI logic. UI logic is going to stay on our front end. But there may be some validation we want to do. The user submits an update. We may want to validate some of that data before we actually do the update operation. And so we want to look at moving what's currently PowerScript data validation code out of the PowerBuilder front end and into the service layer, and let the PowerBuilder front end really focus on just doing the UI work. So remember that I added the PowerBuilder workspace to the Solution Explorer, and there was my list of targets, and then in each target there was a list of pivals, and then the pivals had the objects in them. And what we looked at was right-clicking on a data window and using the converter. What we can also do is we can double-click on a non-visual object or even a window in the Solution Explorer, and that will open up in the C# IDE basically in an edit source mode. But we're not going to be editing it. What we're going to do is we're going to find one of the methods in the or events in the object we've opened, and then we're going to right-click, and there's some options there to either convert it into the clipboard or convert it into the editor. And so this is an example of doing the conversion into an editor. So this is a non-visual object I had where I was doing this converting a number to binary. This is my PowerScript. This is what popped up in the C# IDE when I said open up in the editor, and this is the C# implementation of that same logic. Now what you'll notice here is there's a couple spots where it says PB global dot. Now what Appeon has tried to do is they've tried to do as often as possible is a direct conversion from PowerScript to just standard C#. So for instance, here I would do while loop here, and here's the while loop here. This is just the C# way of doing a while loop. I'm just adding a string together here, doing the same thing here. So that's not terribly significant. But there's other stuff here, like I do a len on the string here. That's done as PB global dot string. No, that's here. That's PB global dot len. Okay. So what that is that there are some things. Blob is a real good example of it, where a blob in C# is basically just a byte array. A blob in PowerBuilder is something completely different. So there is no real one-to-one correspondence between PowerBuilder blob and anything. And so in those specific instances, Appeon has developed another set of libraries that implement PowerBuilder techniques in C#. And that's what this PB global is. This is a reference into that library to do something in C# that isn't really a native C# feature. Now what you could do is, once you've got this converted, it may occur to you that there is a better way that's more standard C# to do the very thing that the PowerScript was doing, and you can go ahead and modify that during your migration effort. Or you could just take what was generated. It's just a matter of whether or not you want to keep that migration library in your application or not. And we'll get into NuGet a little bit later, but this is an example of downloading that PowerScript bridge. That's the library that Appeon's provided that implements the PowerBuilder functionality. So this is shows you where you can actually download that out of NuGet and include it in your project, so that you can handle the stuff that doesn't directly convert into C#. Actually, speaking of NuGet, here we are. Before we get that, before we go to the NuGet, let me step back. Let me demo the PowerScript migration, and then we'll come back to NuGet. Okay, so once again, we're in the C# IDE, and I'm going to pick a different library here to demonstrate the two-factor auth. There we go. The the PowerScript migrator. So here's a couple non-visual objects in here. This one is doing Google authentication for me. So I'm just going to pick one out of here at random. So this is the one that I used to generate a QR code based on well, that's what I'm doing. So I'm going to say translate and open an editor, and it's that quick. Here's the C# code. That's the equivalent for this function here. So it has the coder object, so it's just doing that same call. Now I mentioned that the blob in PowerBuilder is really a completely separate beast than the blob in C#, and that's why you're seeing the PB blob here. Once again, the blob is mentioned here, and then the string functions where PB global gets referenced. But most of the rest of this got converted over pretty cleanly. Let me do another one. Here is this is my num to bin. I think this is the one actually used in the session. Open that up. What I want to show you here, notice the question marks behind the short values, indicating a short in C# doesn't support nulls unless you have that question mark behind it. So this is how they're taking care of little details like that, because in PowerBuilder the int can be null, and you can do the same thing on Windows. So here's a window. Scroll down here, try to find some function or event with some code in it. This one actually doesn't have a whole lot. But here's this one right here, and I'll say open that in the editor, and you can see the code you get here as well. And so once again, we got the blob where we have to use the PowerScript bridge libraries because the PowerBuilder blob is a completely separate animal than the C# blob. Okay. That's pretty much it. That's a quick sample of what the converter looks like. It does operate function by function. It doesn't do a wholesale conversion, and to me that makes sense because you wouldn't want to. I think you'd want to take a function like this, take this code and maybe tweak it a little bit. And so there's a little bit of manual effort. At least that's what I would do. Is I would put a little manual effort in to clean up that code even further once it's generated, and so I would want to do that on a function by function basis. Anyway, that's the PowerScript converter. Okay, so let's talk about NuGet. If you're not familiar with it, it's a package manager for the .NET environment. And as of the time I did this session, it had 154,000 plus packages in it. A lot of them are open source. Some of them are not. Some of them might be what's called GNU license. Some of them might be commercial. We'll go into this a little bit later, but it really does pay to be careful when you are getting stuff from NuGet to make sure that the license that it's provided under is something you're comfortable with. That's my only caveat with regard to NuGet. Other than that, it's great because generally, if you come to a spot in C# development where you say, I need to accomplish this, and it's a pretty complex task, very often you'll find that somebody else has already encountered that issue and come up with the library that does it. And so rather than reinventing the wheel, you can just go and search for libraries that implement the missing functionality, add them to your project, and just start using them right away. There's also private NuGet libraries. So Appeon has one. Some of the commercial vendors such as Telerik and DevExpress, they have private NuGet libraries as well. So if you decide that you're going to buy a product from one of them, they may point you at their NuGet server so that you can download whatever it is, whatever product you purchased. So what we're going to do, I mentioned that there was a utility called Swagger, and what that's about is that the big difference between REST web services that we're talking about here, that we're developing here, and the old SOAP web services is that with SOAP web services there was something called a WSDL file, and a WSDL file was something that a structured XML document that could be machine read, and then client applications could automatically generate classes that could take advantage of the SOAP web services. There's really nothing like that for REST. Generally for REST, what happens is that there's human readable documentation, and the developer writes code based on the human readable documentation and then calls the services. Where does that human readable documentation comes from? Well, if you like to do things the hard way, you write it by hand. If you like to save yourself that work, you use utilities like Swagger, which automatically document the REST APIs. And so that's what we're going to look at. So what I'm going to do is I'm going to go into my project here. I'm going to right click on it. I'm going to say Manage NuGet Libraries. That's going to bring open this dialog here. This is where we can search for things. And so what I did is I searched for Swagger. And what I got in response was a reference to something called Swashbuckler. Now, Swashbuckler is the Swagger implementation in C#. Now, we need to make sure that we get the right version of Swagger. There's a version of Swagger for standard C# projects. There's one for ASP.NET Core. Since we're doing ASP.NET Core, that's the one we want to get. So I'm going to go find went a little too fast there. I find the ASP.NET Core one and click Install. It says, okay, I'm going to install. It shows, first thing it shows you is what I'm actually going to install. So there's the ASP.NET Core for Swashbuckle ASP.NET Core, and then there's these other libraries also related to Swashbuckle that's going to download as well. Depending on what library you download, it may have dependencies on other libraries. And the nice thing about NuGet is that it knows what those dependencies are. It can tell whether or not you have them already, and then if you don't, it can go get those as well. So it's not this hunt and peck operation where you download a library, you just go to run it, and you get all these class not found errors, and you got to try to guess what the dependencies are and where you're supposed to find them. It's just you grab the library you want. If there's other things you need, it goes and finds them for you and installs them all in one shot. So it's really sweet that way. So this is where the next option, or the next item in the dialog that it provides for you, is it shows you the licenses for all the different libraries that you're going to be loading. And this is where you actually want to look at the licenses. What I'd be most concerned about, there's two things I'd be concerned about getting stuff from NuGet. One is that you're downloading commercial libraries. You might be loading a demo version of the commercial library, and you might spend a month or two implementing something and then realize, oh, this is a commercial library, and when you go to look at the price for it, you may decide, well, it's not actually the solution I need because it's too pricey for me, but you just wasted 2 months developing against it. So yeah, don't go there. The other one is that you might find that it's licensed under something such as the GNU license, which I call the virus of licenses. GNU requires that if you are going to use their product, you must also license your product as GNU. In other words, you must give away your source code, which as an ISV, that's not something I'm particularly interested in doing. So I avoid GNU products like the plague. That's why if you use the GhostScript distiller with PowerBuilder, you'll notice that Sybase SAP didn't give you the GhostScript drivers. You had to go download them yourself. And technically, if you use that and deploy it to your clients, if they weren't within your own shop, you should not have provided the GhostScript drivers with your application. You should have requested that your users go download it themselves as well. Because if the users download it themselves, then you haven't triggered the GNU licensing requirement. But if you included the GhostScript driver in your application and you gave it to your customers and you included the GhostScript drivers with it, then technically you should have then released your software under GNU as well. Anyway, don't want to belabor that too much. Just be careful about the licenses. Make sure you hit that view license option and check out the license for the stuff you're downloading. Anyway, I know that Swashbuckler is open source, so we're gonna press on here. So I've downloaded the libraries. There's documentation for Swagger. It tells me what I need to do here. So I need to. This is the startup CS file for my project. I'm going to add a using clause for swashbuckle.asp.NET Core.Swagger. I'm going to go into the configure services section and add a single, well, it's actually a block of code here that basically just says add Swagger gen, and gives it some parameters there. And then I'm also going to go into the configure section. This is one of the few times we actually touch the configure method in the startup CS file. I'm going to go in and say app.useSwagger and then app.useSwaggerUI, and once again there's some arguments that are provided to it as well. The URL it listens on, and then whatever title it's going to display in the page. And with that, we're done. That's all we needed to do to configure to document our services. So I press F5, it recompiles. I go to the URL that I said that Swagger was going to listen on, and I get this page. So there's the title I said I was going to provide. There's my data store demo web service. This was a sample that was automatically generated when I created the ASP.NET Web API service. You can ignore that. But notice, so there's my data store demo. There's the load method. There's the update method. And if you click this get and post, it will pop open more information. So here's the get, and so there's the load for the load method, and it shows, for example, here's an example of the JSON that this thing will return. It's it's hard to see there, but it shows a square bracket there indicating this is array, the name of the class, and then all the different attributes. Now you'll notice there's an execute button here. I can click the execute button and Swagger will actually call the service. So that's really kind of sweet as well. So I can do kind of rudimentary testing of the service, but it just gives you a full set of documentation for all your services. And it took literally like 10 lines of code once we downloaded the libraries. So that just kind of shows you some of the capability that is just available to you with a few clicks of a button out of NuGet. And that's that and many other things that you would normally expect to see in a C# IDE are available in the PowerBuilder C# IDE. So that's NuGet. Let's talk about securing our service now, because what we've done so far is we've put together a service that anybody can call, and in the case of our customers can update. Somebody could go in there and maliciously change our customer data. Well, we don't necessarily want that. So the way we deal with that, there's a number of different ways to secure REST APIs, but one of the more common ones is to use JSON Web Tokens. And so what we're going to do in order to implement JSON Web Tokens is we're going to create another service. And what that service will do is allow our users to log in. And then once they're logged in, we know, well, first of all, we'll require them to log in to use the service at all. And then once they're logged in, we know what roles they'll have. And so we can control, let's say, the update method and say that only certain users can use the update method. They have to have a certain role before they can use the update method. And that protects that data. So what we will do is, what happens with JSON Web Tokens is actually there's a couple different scenarios here. But at some point a JSON Web Token is created, and there's a specific format for that. That JSON Web Token is validated. If that token is validated, usually what happens is that you get a bearer token. That's sent down to the client. The client then includes that bearer token on all the requests for data. And when that bearer token is received by the service, it's then validated. If the bearer token is valid, then the data is returned. And the bearer token usually has a certain lifetime, so that if you've been using the service for a while, your token will time out and you'll have to request a new one or refresh the token, either way, before you continue to use the service. That way you don't have to worry about a middleman getting in there, grabbing the token, and then impersonating your user. So anyway, I got ahead of myself there. We're going to create a user, service, and controller, class, service, and controller to allow us to do the login. Then we'll go to each of the methods in our application and we'll indicate what authentications that authentication is required first of all, and what and then for each particular service, what role is needed to use the service. And then we're actually going to test that using a utility called Postman. So here's what I was talking about earlier. There's actually several different scenarios, and I'm as bad as the Appeon engineers. I call these scenarios 1, 2, and 3 because I didn't come up with a better name for them. So this is scenario 1, and this is what we're going to implement. So we're going to create a service that allows our user to pass in the user ID and password under SSL to secure it. We will validate that username and password. We will figure out what role the user has. We will create a JSON Web Token based on that, and pass it off to an identity service. That identity service is then going to generate a bearer token. We're going to send that bearer token down to the client. That client is then going to request data, sending in the bearer token. That bearer token will be validated. If the bearer token is valid, then we will go ahead and resend data back. And then, like I said, eventually that token times out, and you refresh it, and then you just keep using it over and over again on subsequent requests. So this is the first step here is we need a secret key. So this is my app settings.json. This is where my connection string is at. And the reason I'm doing this, and this is not a particularly secret key. I got ahead of myself there. This is not a particularly secret key. It's pretty obvious what it is, but I put it in the application settings file so that if I've deployed my service and I've become concerned that my secret key might have been compromised, I can just change it in the configuration file and it will automatically get picked up. Restart the service and it will automatically get picked up. If I hard coded in the app and my secret key got compromised, I would need to recompile the app and deploy it, which I don't necessarily want to do. Okay. I'm going into the startup CS file, and I'm going to add basically an instance variable for the secret key. And I've got some using clauses here. This is the ASP.NET stuff for JSON Web Tokens. So we're just going to take advantage of what's built into ASP.NET here. So yeah, there's no special Appeon classes here. We're just using standard C# stuff. And once again, the point is that it's not the hybrid C# stuff that you may have seen in earlier attempts to do .NET from PowerBuilder, such as PowerBuilder.net or DataWindow.net, where it wasn't C#. I called it PowerSharp because it wasn't PowerScript, it wasn't C#. It was some morph between the two, and it had had a lot of limitations. There was a lot that wasn't implemented. There's a lot we couldn't take advantage of. Everything you do in C# you can do in the PowerBuilder C# IDE. Anyway, moving on. This is my class. So I'm going to have a user ID. I'm going to have their actual name. I'm going to have their password. I'm going to have the role that they have within the application. And I'm going to keep track of the token I sent them. So that's pretty simple. This is my user service. This is the interface. And so it's pretty simple. It just has a login method that has the username and password. Yeah, not much else to really explain there. This is the implementing interface. Now, what I'm doing, just for demonstration purposes, rather than having a database I connect to that has a list of users in it, I'm hard coding the list of users right in my service interface, my service implementation class. Literally just for demonstration purposes here. So I only have two users. I have a user called admin, I have a user called guest, and the admin user has an admin role, and guest user has a guest role. Okay, now all I'm doing, this is the implementing class. So I have my login method, and all I'm going to do is I'm going to take that. This was go back up here. This was a private instance variable in the class. So now I'm going to take the username and password that was passed into me and see if I can find the user. If I do, fine. I just return them out of the service. well, actually, when we return actually is the JSON Web Token, but otherwise I just return a null. So this is the ASP.NET stuff that generates a JSON Web Token, and this is where I needed that secret key. So now I'm able to use it. I just declare it as a property, really, of my startup class. This is actually continues on. So this is the top part here. I've just got this key. I've just read the key from the secret key, converted it into a byte string. This is what I'm doing with that. It wasn't quite obvious there because I kind of broke this up. But this is the standard way that you would create a JSON Web Token. There's a username. There's the role they have. I'm setting the timeout to 5 minutes. I'm doing an HMAC SHA using that key that I got earlier in the previous slide. I'm creating a token from that, and then I'm adding it to my user class, and then I'm also returning it from the method. And then this is my controller. This is going to listen for the login attempt, and then issue the token if the login is successful. Nothing special here. This is creating the instance variable of the service and passing it in a constructor. Same thing as we did when we created the original services. This is the actual login method. Once again, this is my user class being passed in, and the only thing I'm actually populating there is the username and password from the client. I just called the service method, and that returns the token, and then I return them. Either it works and I return the token, or it doesn't work and I return an error message saying username or password is incorrect. And just as an aside, one thing to be careful about in a login method is you don't tell the user that you got your username. You don't say something like the password was incorrect. If you got it like let's say you got a valid username but the password was incorrect, you wouldn't normally tell the user in response your password was incorrect. The reason you don't want to do that is because you just told somebody who's trying to hack your system they got the username right, and now they know they can try to brute force the password, the user's password, using that username. That's why my message says username or password is incorrect. I don't want to have a service out there that's giving away my usernames. And I hope that makes sense. You got to think that it's not just your users. This is a web service that may be sitting out there on an IP that can be reached by anybody, and so you don't want script kiddies running out there, at least harvesting your user IDs and potentially brute forcing your passwords as well. Anyway, that was just another aside there. But anyway, that's the login method. Okay, now to make sure, because I'm passing a username or password, I want to make sure that the user doesn't try to call this login method from standard HTTP, where the body of my request would be in clear text. I want to make sure they're always using SSL. So we're going to encrypt the username and password that's being sent to us. And so this is the one other place that we're really going to go in and touch the configure section of the startup.cs file. I'm going to first of all use app.use authentication. This turns on all the authentication services within ASP.NET Core. The second one is I'm going to use this app.use HTTPS redirect. All that does is it says, if you send me an HTTP call, I will redirect you automatically to HTTPS. You cannot make HTTP calls to this service. Okay. Then I'm going. This is more of. I should. This is more of. Oh yeah, this is in the. I really don't show it here. This is part of the secure services. Configure services method. So that's my fault there. I say it here, but it really should show on the slide as well. Anyway, so once again I'm reading the key, the secret key. I'm setting that to the instance variable on my startup class, so I can reference it for my login service. I'm adding the authentication. So I turned on the authentication services in the configure section, but now I'm indicating that it's JWT bearer that I want to use, and so I'm configuring my JWT bearer here. And so there's a bunch of different options here, but and you can look into what all the different options are here, but this will get you started. Oh, and sorry, right here at the bottom, I've got that user service. I need to make sure that I do the add scope call for it, so that it starts listening on the URL. So now I have a user login service. Okay. Now we have a login method, and now we know that we can use JWT authentication. The problem is that right now my service still isn't controlled. I actually have to, indicate to the service what you need to do in order to use these methods. So I'm going to add a call using clause for ASP.NET Core authorization here. I'm going to go in, and each method that I want to protect. Now, if I don't add this, it's still going to be accessible just via straight URL call. You won't need to log in to use them. The minute I add this authorized declaration to the method, it now requires that you log in. And what you add in as part of that declaration are the roles that are allowed to use the service. So notice that this is my load method. Both the admin and guest roles can use the load method. But notice my update method, only the admin user can call the update method. Or actually, it's not the admin user, it's the admin role. Any user has the admin role. In my case, it's just the admin user. But anyway, you have to have the admin role to call update, but admin and guest can use load. And at that point, we're done. We just compile the app. And now when we hit it, and I'll show that here in a minute, this is Postman. It's a great utility for testing REST web services. It's kind of like SOAP UI was or is for SOAP web services. And so I put in the URL for the method. Now, if I didn't have services on, if I didn't have the JWT authentication on, if I just hit send, I would have gotten data back. Now when I hit send, I get a 401 error back. It says you need to authenticate before you can use this service. So now what I'll do is I'll put in the URL for the user login. I'll go down here and indicate that my body type is raw, that it's JSON, and I'll put in a JSON payload that passes in the username and password. So in this case, it's just admin. And I will hit send. Now that will work, and what I'll get back in response is just a bearer token. I copy that bearer token back into the original service call. I go to the authentication tab, indicate that I have a bearer token, paste it in, hit the load method, and now I get the data back. So now I am able to call it because now I have authenticated to the service. Okay, this is how we do the same thing in PowerBuilder. Now I know we haven't actually looked at how we call the service with PowerBuilder yet. We'll get into that here in a little bit. But here's how we authenticate using PowerBuilder. So now I'm going to create a JSON payload here. Now I just happen to just type this in. You could use the JSON generator to put it together if you want, or you could parse it together. I've kind of hard-coded it here, but that's my JSON payload. I'm going to use this is the REST client. I'm going to use the get JSON web token token. That's kind of redundant, but anyway. This is my login method. And notice, even though it's being sent on HTTP, it's going to get automatically rejected to HTTPS. There's my data with my username and password. I get the token back as a response. I call client.setJWT token and just give it the token, the bearer token. And at that point, every request that the REST client makes from that point on will just send that bearer token, and we'll get the data. Okay. So that's JWT. Now let's look at testing the service. A couple of different ways we can do that. This is an example. I mean, and it's something I've used before, is the idea of using Postman to do it. Postman is free. It's pretty nice. You put in the service you want to call, hit send, you bring back the data, it can handle authentication. It gets a little bit more problematic when you want to test something like an update, though, because what you have to do, what I end up doing a lot of times, is I do a get, I copy the JSON out of the get, and then go to my update, and I paste it back in again, and I change some values. And so it's a little kludgy that way, but that's just the nature of the business. But there's a better way. There is something called, and this is a 2019 R2 feature, the Web API Tester, built right into the IDE. So what I've done here is I've gone to the controller, and I found a method in the controller, right-clicked, and I select Run Test from the pop-up menu. That will pop open this dialog. And what it will actually do is will read all of the methods in the controller, even though you just right-clicked on one of them. And so here it shows my customer's controller. There's the two, my retrieve, my update method. Here it's showing the retrieve method in the tester. And notice, remember I talked about where I passed in a positive value, it would return me the single customer, and if I put in a negative value, I get the whole list. So I'm passing in a number here, just so I can retrieve one customer. And so that's my my arguments here that I'm passing in. Also, keep a history of all the calls you've made, and so if you want to go back and redo a test, you can just go back into your history as well. Okay, and you hit send, and then you get the JSON back. Now I've asked, this is of course, this, as I mentioned earlier, we are in beta at this point I'm doing this session. This particular feature is in beta. I've asked that we got a JSON parser for this, just to make it a little easier to read the response here. But there's the data coming back. But what's particularly nice about here with this Web API tester, here's my update method. So there's my update URL, but notice these buttons here on the upper right, and this first one says retrieve. So I click that, and it will prompt me, well, how do you want to retrieve this data? And so I'm going to put in my retrieve method and do a retrieve. And back comes a bunch of data. Now notice I've got some additional options here. So what this does, this says clear this row from the result set. This says clear all the rows but this row from the result set. This means, you can hardly see my pointer there, delete this row. And there's also this plus up here which will add a new row. And that way you can go in, it's much easier. I don't have to do a retrieve, cut and paste some JSON, paste it back in, and manually edit it. I can come in, I can do the retrieve right from the update method. And then I can just hit this, delete a row. I can go in here and change values. I can do a plus here and add a row. So I can simulate all those methods or all those updates, but it's a much simpler to do here through this interface. And then at that point, then you go to the body section. Now this is before I've issued the update. The body section shows what is going to be sent back to the service based on the changes you made on the previous screen. Now we're doing this remember I talked about the two different JSON formats. There's plain JSON and there's data window JSON. Now this is this data window JSON, so it has metadata in it. For example, there is a column status, which indicates that whether or not a column's been changed. If their column's been changed, there'll be an original and current value of the column. There's a row status information. In this case, I did a delete. Notice there's the primary rows, there's the filter rows, and here we have the delete rows. So this is where the row I deleted shows up in the delete rows. This is the delete buffer. So it's real nice for you make your changes in the painter, if you will, but then it shows you what the JSON that you are generating will look like. And then you can issue the update and make sure that it works. So that's great. That's great for manually testing your service. And what's really good about that particular approach, like Postman, is you're testing right at the URL level. Because you think about it, there's the URL, that triggers the controller, that triggers the service, that triggers the model. So you're really testing using either Postman or the Web API tester. You're really testing from the URL level down. What we're going to talk about next is unit testing. Now unit testing is a little bit different because you tend to test at the controller method level, which means the URL isn't necessarily being tested, if you follow that. But it has some important features here. It means that there are reusable tests, what unit testing involves is reusable tests. In unit testing, you test individual functions, and each test is independent of other methods. So you're not daisy chaining together unit tests where A has to work before B can be tried. Unit tests should not cross boundaries, and we'll get into that later. That's more of a sort of a religious argument. But the idea is that unit tests shouldn't try to be doing integration testing. In other words, what it really gets to is you really shouldn't be testing your data source. You should only be testing the service itself. And unit tests are rerun on a regular basis. So, for example, my shop, we're actually Java-based. I use Gradle. We use Gradle, which means that whenever I do a build on my local machine, one of the things I have is I have a copy of all the unit tests that not only that I've created, but all the other developers have created. When I go and make changes and I do a Gradle run, it reruns all the unit tests. And that way, that's really instantaneous feedback to tell me if my changes just broke somebody else's work. So I don't find out 2 or 3 months down the road, I find out right away. Or even broke some of my earlier work. The other thing is the unit tests also get run whenever we do our daily builds. We're doing continuous integration. I mean, we do at least daily builds. So every time a build is done, the unit tests are also rerun. And so if there's a break there, we find out right away. So that's really what unit testing is about. It's just continuously testing to make sure that as new stuff is added, old stuff isn't broken. So in the C# IDE, the way we're going to do a unit test is to in their same project or same target, we're going to create a new project, and where it's going to be a XUnit test project. Then we're going to add a reference. So we right-click on the project, say Add Reference, and we're going to reference the project that we want to test. So I'm going to be testing my data store demo. Now, the XUnit testing is more generic, and so it doesn't have things like dwnet.data in it as one of its libraries. So we're going to have to add that. So I'm going to add dwnet.data, and notice that it will pull down a bunch of, this is where I was talking about how there are other libraries that it will need to pull down if there are dependencies, and that's what it's doing here. And so you can see there's a license for each one of these that you might want to look at. Also, like I said, XUnit testing is generic. It's not even specific to ASP.NET Core, so it doesn't have the ASP.NET Core libraries in it. We're going to have to download that as well or reference it in our project. So I'm going to do that through NuGet as well. And one thing we're going to need to do is we have that app setting .json file that has our configuration, or particularly our connection string in it. We're going to copy that over into our unit test project because the app is going to have to reference that at runtime. And remember I talked about you might want to set a property on the file to have it copied into the bin folder, and this is what we're going to do in the test project. Is we're going to make sure that we go to its properties and say copy if newer, and that makes sure that when the app is compiled, this unit testing app is compiled, that configuration file is copied over into the bin folder with the application. Okay, so this is my unit testing project, and now what I'm going to do is I'm going to add a whole bunch of using statements. So I've got a using statement for the models folder of my service, for the services folder, for the service implementation folder. I'm adding a reference to extensions.configuration because, but you know, like an ASP.NET application already has configuration built into it, but this unit testing project doesn't, so I have to add a using clause for it for dependency injection. I'm adding the data.net data as well as the snapobjects.data and .SQL server because we're going to be using all that. Well, we are in my initial implementation. Remember I said you don't test the database layer. I'm going to show where you can avoid doing that, and then you can decide which approach you want to take. Okay, so this is a file called, well, it's called PB Unit Test Host. We need to be able to load data, the data stores, and so we need to have this file that kind of implements that data window technology. Remember in the startup CS file in our ASP.NET web project, I had all those .use PowerBuilder integrated and use data window. We need to have sort of those same calls, and that's what this class does, is it gets that data window technology configured for us. So I create a class, I call it PB Unit Test Host. I'm implementing the data store host interface. And I'm going to override the configure services method, and then I'm just going to call, basically this is calling the ancestor right here. Okay, so that's what I've got so far. Now I'm going to add in a call to configuration. This is what we need to actually read the configuration file. Like I said, ASP.NET Web API configuration is built in. I didn't have to take this step. XUnit, it's not built in. We have to kind of manually put this together. So this is us reading the configuration file. I'm going to do this. Basically, I copied and pasted this out of the ASP.NET Web API service. So I'm going to add the data context, and I'm going to add scoped for my service that I'm testing. Okay, now I've gone back to my unit test project, I'm going to add using clauses for DW.NET data, dependency injection, the models folder, and the services folder. And in my unit test, I'm going to say that this is implementing the iClass fixture interface, and it's going to take that PB unit test host class I created as part of the argument there. So I'm creating a instance variable of my of the data context of that PB unit test host. I'm creating a custom constructor for PB unit test that takes the test host and then setting the instance variables based on that. Okay, now here's the actual test methods. That was all framework stuff. Here's where we're actually putting together a test method. So here's my first test method. I'm going to say I'm going to create my actually, when I get to my sample, I've got a better version of this. But I am going to get the service from the host of the iRest demo service, and I'm going to call the getAll method. And then I'm going to check to see if the row count from the in the data store is greater than 1. If that's true, then my test worked. I was able to retrieve data. So that part's pretty simple. You do one thing, get all, you check to make sure that it worked with an assert statement, and if that assert statement is true, your test worked. Otherwise, your test failed. Now I right click and I say run tests, and it will run the tests and indicate whether or not it worked. So I said, your data, your service, your unit test shouldn't cross boundaries, but that's what I did with that first one. Because what did I do? I called the service directly, and that service used the data context to go retrieve data from the database. What I meant by crossing boundaries is idealistically, your database is a separate layer, and it really shouldn't be tested as a part of testing your service. Well, how do you test your service without hitting the database? Well, what you do is you create a mock service. That's what we're going to talk about here. There are some reasons that you want to consider doing this. One of them is that if you're using real data, it's hard to create reproducible tests. You have some customer 100, and maybe you test updating his salary, or not customer, you wouldn't give a customer salary, but you update his address, let's say. Well, other people could be working with that same data, and they might delete that customer, and then your unit test is going to fail because the customer that you're using for unit test doesn't exist anymore. That's kind of oops. When you create a mock service, you've got this fixed set of data, and that way that's built into the service, the mock service, and that way you don't have to worry about other developers wiping out data that you're using for testing. It's built into the service, the mock service. It's not going to get clobbered. So it helps to make reproducible tests, and as I mentioned here a couple times, it eliminates the database as something that can cause unit test failure. Because if the database developer, it's assuming it's a separate database developer, it's not you. If he goes and changes the data model, obviously that will eventually mean your service will fail. But that's not a result of changes you made. That's a result of changes he made. And what you're testing for is to see whether or not changes you made broke this. I hope that made sense. So a mock service, or I said mock controller here, I mean a mock service, allows the data to be recreated for each run, and that way you get the reproduced results. Now, I'll mention here that's considered a best practice. It's not always implemented. My shop doesn't do this, and one of the reasons is it takes a lot of work, or it takes more work, I should say. There are libraries out there that will create mock services for you, but creating a mock service does take some additional work. It's an additional set of classes you have to maintain. So when you change the service, you have to go change the mock service as well. And to some people's minds, including mine, testing a mock service means that you're testing the mock service. I don't really feel like it's really testing. It is not really quite testing the service. And so what we do in my shop is we just deal with the data issue. So we just realize that's an issue, that's a problem, but we go ahead and test from the service down to the database layer. Anyway, so that's something you need to decide on your own, whether you want to use mock services or just go ahead and hit the database. Anyway, so this is an example of how you would create a mock service, though, if you're going to do that. So this is one of the cases where interfaces are getting used. So I'm creating my mock service class, but it also implements the same interface as my regular service, and that's what makes them interchangeable. They're not inheriting from the same thing; they're implementing the same thing. Now here's my getAll method, but notice my getAll method is hard coded. I've got a list of employees here that I've just hard coded into the result and sending it back. Now I haven't implemented the update method here. I'm just showing this for demo purposes here. So this is how you would test using a mock service. So instead of creating the service from the normal service, you create it from the mock service. Then create the controller using the mock service as the argument, and then retrieve the data. And then check to see if the data that got returned is greater than 0, and then that means it worked. Okay, so let's take a break, and I'm going to demo both the black box testing using the Web API tester and the unit testing, and then we'll come back and we'll talk about deploying the service. Okay, we're back in the C# IDE, and this is the scaffolding demo that we created earlier. And so first thing I'm going to do is, well, I didn't want to do that. I just want to go ahead and run this. I'm going to hit F5, and we haven't made any changes, so this will actually start up right away. And so our service is running, and of course the browser went ahead and retrieved the data. I can take and copy that, and then this is Postman. This is the first utility I talked about, which is good for testing APIs. And I'll go ahead and create a new request here, put in that same URL, and we get data back. We get it formatted a little bit better than the browser does. Now, if this was a plain JSON service, then I could go in here and I could put in be a post request and the update, and put in a body here of JSON, and I could copy this over and then make changes to it, and it would perform an update. The problem is that at least for using Postman, is that this is a .NET data store based service, and so it's expecting the data window JSON format, which I wasn't getting in the retrieve. I was just getting plain JSON in the retrieve. So that's not going to necessarily work well for us for testing out that particular API. So we're going to look at another approach here, and I'm actually going to shut down the service to make this happen. I'm going to go to the customer controller, and I'm going to right click in a method. I'm going to say run tests. It's doing a debug build, which is why it's taking a little while. Okay, and then it fires up the Web API tester. And notice it's actually got, I didn't need to paste anything in. It's already got the methods defined by reading the controller. So now I can do a retrieve here, actually that is an update. That here we go, the retrieve here. So there's my data, and I have indicated that I'd like to see this in a parsed format, much like the way Postman does it, rather than just the block of JSON here. But let's go to the update method, and note, and this is the retrieve button I mentioned earlier. So I hit the retrieve button, and by default it chose the retrieve method as the method it's going to use to do the retrieve, which works. So I'm going to do the retrieve there. That is going to give me a bunch of data here. And now this data, if you go to the body, this is in the data window JSON format. And if I wanted to cheat, I could actually copy this out and go back to Postman. I don't think I actually saved those requests, though. We'll see here in a second. Oh, they're still there. And I could put that in the body. And then I could go ahead and make changes and actually test test it through Postman. But let's just do it right here. This is even better. So go back to the parameters, and so these are this is to delete this row. So if I delete that row and then go back here and look at the body, notice the delete buffer was empty last time. Now that delete buffer has a row in it. That's the row I deleted. I can wrong tab, sorry. Go back to the parameters. I can say that I want to add, and inserts a new row here, and I could put in some values and go back to the body. And if we scroll, probably I'm going to assume this is right at the very end of the primary buffer. Yeah, there is the record I just added. And if we look at the row status, notice the row status is 3. And so that indicates an insert. Where if we look at the other rows, this is metadata. There's the primary rows. Oh, this says 3 as well. Wait a minute. Oh, okay. I see what's going on. The only row that's in the update is just the row I added. Okay. So let's go ahead and modify one. Oh, wrong tab again. Sorry about that. Parameters. Let's take one of the other rows and modify it. So we'll make this G. Keep in mind what it was I just changed there, because now I'm going to go to the body. Okay. Now I have get to pass the metadata here. Note to self, ask for collapsible in here. Anyway, here's my row to status 1. That's what I was looking for. So this is a modified row. And then if you come down here, notice that for a lot of the columns, you don't have any information other than the data value. But for the middle name, which is what I changed, there's the original value, there's the modified value, and there's the one indicating this is the modified column. So that's how we get that optimistic concurrency in the data window update, is by having the original value returned in the REST call. And then we can actually send that. It said it worked. So let's go back and do a retrieve. Let's check the first column. Notice that what was the first column is gone. This is the second column that's got the changed middle name, and this last column down here is likely me. Yeah. So it worked. That's great. But this is the other cool feature. So let's say, let me close this out. Let me go in here in the update method, and let me put a breakpoint right here. Okay. Now I'm going to go in, right click, and say debug tests. And this you can't do with Postman. This is something you can only do with the web API. And I didn't actually include this in the slides, so I probably need to update my slides. Okay, I must have clicked on something wrong. I'm going to try that again. Debug test. I may have clicked outside the method body, and so it just didn't do anything. So it's firing the debug build now. Okay, I'm going to back to the update method. I'm going to do a retrieve to get some data. There's my data. I'm going to take that first customer. I'm going to change their middle name back to F. I'm going to hit send, and we drop into the debugger, and I can actually step through the code at this point. Okay, so that is slick for not only testing but for debugging your services. So that's black box testing. Now we're going to look at unit testing. But to do that, I'm going to open up a different project, one where I've already got the unit test written. And that will be this one right here. Okay, and this is the same one I used in the slides, although I have changed the unit test itself. In my slides, I was doing this get service, which didn't really test out the controller level. And so what I've replaced that with is this code right here, where I'm creating the service using the data context, creating the controller using the service, and then actually making the call right at the controller level. And so I feel like I'm being a little bit more thorough with my testing here. That, like I said in the session, the slides, I'm not really testing the URLs. That's something that the web API testing or calling it through Postman do. But we're just calling it at the controller level. So that's the one piece we skip. So anyway, since I'm calling the controller, I'm actually getting an action result back, and then pulling the list of customer data off of the action result, and then checking for the count is greater than 0. Same thing with both the mock test and the actual live data test. So I can right click here. I can say run tests. And it ran both tests, and oh, failed. That's interesting. Oh, 0 failed. Okay, my bad. It's got green. I should have realized that. Okay, so here's my unit test 1. Here's test 1, 2. That's 2. I can also go in here and I can rerun them, or I can debug them. Actually, I need to set a breakpoint before I run off and do that. So now I can debug, and that's stepped into, or should step into, the controller. Yeah, there we go. And now I can step over or step into code. Okay. So we can do debugging here as well through the unit testing. Oh, that's not primarily what it's used for. It's primarily used for testing whenever you do a build, just to make sure you didn't break stuff. It's more specifically intended for that, but you can debug as well. Okay, so that is black box testing and unit testing. Okay, so let's look at deploying the service. And like I mentioned much earlier on, I'm going to be using Amazon Lightsail, which most people don't know what it is, but it's Amazon's version of something like HostGator, where you can host web services on a machine in a cloud environment. One thing I particularly like about it is I do get a lot of access to the machine itself, sort of like using a shared environment with something like HostGator. And so I'm able to do some stuff that you normally don't get to do if you're just deploying services. Anyway, so something to be aware of here is that by default, ASP.NET Core Web Services run within the Kestrel web server, which is part of ASP.NET Core. What Kestrel is, it's a cross-platform multi-platform web server. So you can actually, it doesn't require Windows. You can run this on Linux as well. And you can use Kestrel by itself, or you can use IIS, Apache, or that third server that I don't know how to pronounce the name of, as a reverse proxy in front of it. Now, there are some advantages to using one of these other servers as a reverse proxy. Wrong direction. If you want to support hosting multiple services on the same port, or if you want to support host headers, or particularly in the case I'm looking at, if you want to have an easy way of implementing SSL, then you might want to look at using a reverse proxy. And that's what I'm going to do here. I'm actually going to use IIS as the reverse proxy for Kestrel. The argument for doing the other is that Kestrel apparently is very fast, and you may actually be slowing yourself down by using one of these more bloated service web hosting environments. But anyway, so it's a trade-off, and you can decide which way you want to do that. So first thing I'm going to do is I'm going to go in and publish my my data store demo service. So I right-click on it, hit publish. Now we have three options. We can do a web deploy. That means we're going to deploy directly to the hosting environment. That's not an option for me because I'm on Amazon. I have to FTP or otherwise transfer files to the server. What I actually do is I use Google Drive for that. So I'm going to use the file system approach to create a zip file and then send that up, and then copy that up to the server and unzip it there. The third option is Docker. This is another 2019 R2 feature, so that you can deploy it to a Docker container. So I indicate that I want to do the publish, hit publish, and you can see all the different files being copied down into the output folder. Then I zip that up and copy it up to the web server where I'm going to have this deployed. I unzip that into a folder. Now this is in the IIS manager. I'm going to say add website, and then I give it a name. I just point it at the folder that I put the unzip the files into. And in this particular case, I'm actually going to have it listed on a different port because I've got something else running on the 80 port. So I'm going to be listed on 8080. Now, in this particular case, I've got IIS there, but I don't have ASP.NET Core, the runtime, and so I need to download that. So I'm going to go to the Microsoft site, get the ASP.NET Core runtime, install it on the server, and that will, of course, install Kestrel as well. I need to make sure that I grab the runtime, though. That is the runtime that the C# IDE targets, which right now is 2.1.1. Support for 3.0 just got released just recently, so support for 3.0 is coming in a later release of SnapDevelop. So right now we're using 2.1.1, and then I go to the URL that this is on the local machine itself. It's using localhost. And called the load method, and I got data back. So yay, this thing works. It was a pretty easy deploy. But the problem, at least in the Lightsail environment, is that the localhost is the only thing that can see that service right now, particularly because I use the non-standard port, the 8080 port. So what I need to do is I need to create an exception in the firewall, the Windows firewall, to allow machines outside of the web server itself to access that port. And so I'm open up from Windows Firewall, indicate I want to create a new rule, a new incoming rule, and choose the port, in this case 8080, indicate that I want to allow TCP access, that I want to allow the connection. I left these as the defaults right here, and then I give it a name. That way when I come back to it later and I go, well, why is port 8080 open on this machine? Oh yeah, it's that web service. So I give it a name and I'm done. Now what that did, at least in the Amazon Lightsail environment, is that opened up that port to other machines within the Lightsail environment. What I haven't done though is expose that to the web in general. And to do that, now I need to actually go into my Lightsail configuration. And there's a firewall in the Lightsail configuration. This is a website I go to manage the Lightsail. And I add a new rule in the firewall there, once again for 8080, and indicate that I'm allowing TCP on that connection. And that's what exposes now the web service to the world. And now I can call the web service using my domain name that I have for my Lightsail instance, and I get data back. So we've deployed the service. So finally, we've got a service that's out there, it's secured, it's available on a public IP address. Let's use it from PowerBuilder. So as I mentioned here a few times, you have a choice between client agnostic and PowerBuilder specific REST API approaches. We're going to do the PowerBuilder specific version. I'm going to use the REST client object in the PowerBuilder client to call it. Actually, I said SQL Model Mapper service shown later, but actually I showed that already. So this slide was originally earlier. The client I've created actually uses the REST client, but it's actually capable of calling both of the services using the data window. So once again, I mentioned that the data store and the data window can by default generate data window JSON. They can generate plain JSON, and so we're going to look at doing it both ways. So and once again, the SQL Model Mapper does just the plain JSON. The data store, .NET data store on the server side, by default does the .NET data the data window JSON, but it can do plain JSON as well. So you could have, like if I use the template C in my when I did the scaffolding, I would use .NET Data Store, or could use .NET Data Store to support both client agnostic and PowerBuilder specific methods. It doesn't have to use SQL Model Mapper, but we're going to show using the PowerBuilder to call both SQL Model Mapper and Data Store. So look at some of the code here. This is what I just explained earlier. So look at some of the code here. What I did, here's a data window, obviously. I've got a drop-down list box that allows me to choose between which of the two approaches I'm going to use, either the client agnostic or the data window specific. I have a retrieve button that's actually going to call the load method. I have an update method that's going to call in the data window specific version, is going to call just the update method. It's going to send all the updates in a single call. In the SQL Model Mapper or the client agnostic approach, what the update method will do is it will call the individual add, create, and delete methods. Add, delete, and update methods, because it's the stateless approach. There's insert and delete, but all those do is just do inserts and deletes in the data window itself. They don't call any services. This is an instance variables on the window, so I just have my REST client as an instance variable, and that way I don't have to recreate it every time. I also have an instance variable that keeps track of which service was selected in the drop-down list box. This is the open event of the window where I just create the REST client. And there's a couple of settings I would just want to set initially on the REST client so that it just continues to use that from then on. One is to set the content type to JSON, char set UTF-8. And the other is to do the accept encoding. And I kind of skipped over that maybe a little bit in my original talk about the service. But there was an option turned on by default when we created the ASP.NET Web Service that turned on gzip compression. And what that means is even though the data is in JSON format, if gzip compression is turned on, what the server will do is whenever it sends data down, it will zip it into a gzip format first, send the gzip down, and then the client can unzip it and then pull the JSON out of that. What that does is that it dramatically increases, or decreases I should say, the size of the data, which correspondingly increases the speed of the service because it's not transmitting as much data. And so that's turned on, at least in ASP.NET Web API, that's turned on by default. Doesn't mean that it's always sent. And this is the flag the client sends to say, I support gzip, go ahead and send me the gzip data. So if the client doesn't send this, then the server won't gzip the data. And correspondingly, if the service doesn't support it, the client could send this flag, but the server will ignore it. It won't gzip the data because it doesn't support it. And then it will just send back plain JSON. So this is just saying, if you support it, go ahead and send me the data that way. If you don't, then I'll just get JSON. Anyway, and then all this does is set the default item for the dropdown, which is the .NET Data Store approach. This is just the retrieve event for the data window. So once I get data back, I enable the insert and delete buttons. Delete makes sense. I mean, you can't delete rows that aren't there. Maybe I shouldn't have done that to the insert, but doesn't matter. Then this is the selection changed event for the drop-down list box, and it just indicates, it lets the instance variable know which one of the two services was selected, whether the .NET Data Store or SQL Model Mapper. This is my insert button, and what I've done here is I've cheated, because what I've done is I've just hard-coded the data I'm gonna add. That way I didn't have to add it. This is just for demo. So I didn't want to have to type in all the values. I just hard-coded it. But anyway, I'm doing a get row. And now this is a new 2019 R2 feature, import row from JSON. That gives us the ability to import a single row of JSON. Rather, in 2019 you can import a block JSON, but you can import a single row. And so that's an added feature now. Now when that gets added, it's going to be set to a not modified status. And so because I want this to result in an add, I'm going to change the item status flag so that the data window knows this, or data window flags it as an added row, new modified rather than not modified. This is just the delete row, and it's pretty simple. It's just a standard JavaScript delete. I have a get URL method. So when I call my the other methods, I know what the base URL is, and I can just add on the method name, whether it's load or update or add or delete. And it's using the service name, the service that was selected, whether it's a data store or a SQL Model Mapper, to determine what the base URL should be. And then this is the retrieve. I'm not sure why it doesn't show the name of the. Well, it does show the name of the control there. It just looks a little odd right there. Anyway, this is retrieve. Now notice I'm doing a reset on the data window because if you do a REST client retrieve and there's data in the data window already, it just adds it on. So I'm going to reset the data window. I'm going to get the URL, that gives me the base URL, and add the load to it. So I'm calling the load method, whichever one it is. And I made sure that, at least for the load and update, I made sure the method names were the same in the two services just to make it easier to recall here. So this is REST client, and the REST client has a retrieve method that takes the data window in by reference and the URL. Okay, this is the update button. And now this is actually just the first part of it. So I'm doing accept text, that's kind of standard stuff. I'm getting the base URL, which I'm going to then use to call either the single update function or the individual functions down lower. So this is in the case of service 1, which is our .NET data store. If the .NET data store is being used, then I can send the inserts, deletes, and updates in a single call, and that's what I'm going to do here using the submit method of the REST client. So I just call the update method. That takes a string by reference, which the response is returned to. So if an exception is thrown, that's where I'm going to get that information. I pass in the data window, and there's a couple flags in here. The first one indicates whether or not I'm sending all the data or just the changes. The second one indicates which format I want it in. Remember I said the data window gives you choice about REST, whether or not it sends data window JSON or plain JSON. This is that flag. So if I send the, if I set this to true, I get data window JSON. If I set to false, I get plain JSON. Okay, so that was pretty simple. That was really simple. That's that. The update there is if you're using the .NET data store, you just call that one method. You're done. This is the SQL model mapper, or even the .NET data store. If we're using the client agnostic approach, where we're using plain JSON. This is where I need to call 3 methods separately. And so what I'm going to do here then is, if this is the case 2, which is where we're doing the client agnostic approach, first thing I'm going to do is I'm going to loop through the data window looking for inserted rows. If I have an inserted row, this is another 2019 R2 feature, the ability to export a row as JSON. I'm going to do the export row as JSON to get that one particular row. Now, this is another 2019 R2 new feature. The REST client has a set of send methods that are HTTP verb specific. So there is a send put request, send delete request, send post request. So we're going to be using those for the individual methods. Those take the URL, the data, and then have a string passed in by reference, which returns the response from the service. So if an error is thrown, that's where you get it. So I'm going to take. We're back to the insert. I'm exporting each row, and then taking that row and putting it into the put request, because I mapped the add method to put, which is pretty typical. It could have been post as well, but and then sending the row and getting the response. So that takes care of all the inserted rows. I'm going to get the deleted count. I'm going to loop through the deleted buffer now, pulling off just the customer ID. Because in order to delete the customer, I really don't need the entire customer row. I just need the ID value. And so the way I coded it, my delete method just takes the ID value. And I'm using delete as the method there for delete. And it could have been post as well. It just depends how you want to implement your methods. But anyway, I call the delete method and pass in the ID value. That takes care of my inserts, my deletes. What's left is just my updates. Here I'm going to use export JSON. I'm going to say give me the modified values, but notice I'm putting a false here. This says give me plain JSON. Don't give me the data window JSON. This just gives me a list of updated rows. Now it doesn't tell me what the updates are. Remember, this is plain JSON. I'm just sending back the updated rows. Now it doesn't tell me what columns have been updated, I should say. And I'm sending that via post request. So this sends a row at a time. This essentially sends a row at a time, or actually an ID at a time. And this just sends the rest of the updates in a single call. But those are just updates. Now at the very end, now because I didn't use the standard update methods of the data window doesn't know that what changes were made as far as the database is concerned. And so I'm doing a reset update on the data window to let the data window know I've taken care of those updates, set everything back to not modified. Okay, let's we'll do a little demo of calling the services using the PowerBuilder client, and then we'll move on to questions and answers. Okay, so this is in this particular solution, I've got 3 services. I've got the .NET Data Source service. It has all 5 methods: load, retrieve. I'm sorry, the load, update, load 1, add, and delete. Although the only 2 I'm actually going to use here are the load and update, because I'm going to take advantage of the fact that the .NET Data Store can take the add, deletes, and inserts in the single update method. And then for the SQL Model Mapper, it also has all the methods, but we're actually going to end up using all the methods if we do the update through those. And then this is the user controller you saw from the JWT demo. So the user that can log into the service. Now on what I've done in here is I've actually commented out the authorized declarations. So we're no longer using authentication for the service, just for the purposes of this demo. So this is running in the background. Oh, that's SOAP UI. I don't need that anymore. So here's my sample app. And it does have the login method down here. That will call the user controller and get a JWT token and then send it on each request, but we don't need that right now. So I'm going to retrieve the data from the database, and so that was pretty quick. Let me try. I'm going to delete that row, and maybe I'll change Rosemary's middle initial there. I'll hit update. I'll hit retrieve, and so that row is gone, and there's Rosemary with her changed middle name. And I'm going to change that again, and maybe insert a row. So I'm going to insert myself into the database. Yeah, there I am right there. Do the update. Do the retrieve again, and I'm down here at the bottom now. But then Rosemary's got the, I mean, I actually don't remember where it was, Lucy or Rosemary I changed, but anyway, they got changed because they used to both be G. Okay, so that's the data store. That's the one where it does retrieve in one method, update in one method. The other approach is SQL Model Mapper, and I really don't, well, I'll retrieve again, but I didn't really need to do that because it pulls back the data exactly the same way between the 2 methods. The difference is now I'm going to go ahead and delete this guy. Well, that's me, by me. And then I'm going to change this to maybe F. And now when I do an update and do a retrieve, I'm gone, and there's the F. But that was 2, in the background, that was actually 2 separate method calls. And sometimes you can see this in the window back here when the updates are being made, because I was doing a delete and a modify, and with a plain JSON, those are 2 separate calls. Same thing if I insert myself back in and maybe change one of these other values and do an update. Yeah, I'm not seeing it for some reason in the back here, but or else it just looks exactly the same. But that was 2 separate calls once again, because the add is separate from an update, as separate from the delete. So not that it seemed to make a whole lot of difference as far as performance here, but That's how that works. So anyway, all the sample code will be available on the Appeon Code Exchange site, so you can pull it down and tinker with this yourself. Okay, so that's doing an update from the PowerBuilder client, and we're going to go back and take questions.